The 30-meter telescope is almost here, and it's ready to take grounded space exploration to another level. With more than $2 billion invested into its construction already, several countries have given scientific assistance and government-level financial support towards the 30-meter telescope, which, when completed, will be able to observe space and detect alien life with much more accuracy than any other telescope in existence. But what is the TMT planning to explore, and to what extent can it go? Let's take a look at one of the most awaited and controversial telescopes of all time. The 30-meter telescope, also known as the TMT, is one of a new class of extremely large telescopes, or ELTs, that will allow us to see deeper into space and observe cosmic objects with unprecedented sensitivity and detail. It was designed and developed by the TMT International Observatory. And speaking of design, let's take a look at what exactly the TMT will look like and how it will function. Its 30-meter diameter prime mirror will enable observations from ultraviolet to mid-infrared wavelengths with up to 80 times the sensitivity of today's largest telescopes. 30-meter in the title refers to the 30-meter diameter of the mirror, with 492 segments of glass pieced together, which makes it 3 times as wide as the world's largest existing visible light telescope. The larger the mirror, the more light a telescope can collect, which means, in turn, that it can see and capture farther, fainter objects. The Associated Press quoted Christophe Dumas, head of operations for the TMT, as saying that it would be more than 200 times more sensitive than current telescopes. State-of-the-art adaptive optic systems will help correct significant image blur caused by the blurring effects of the Earth's atmosphere, and will deliver images at infrared wavelengths that are more than 12 times sharper than those of the famed Hubble Space Telescope and 4 times sharper than the James Webb Space Telescope. Scientists have been considering ELTs since the mid-1980s. In 2000, astronomers considered the possibility of a telescope with a light-gathering mirror larger than 20 meters in diameter. However, the technology to build a mirror larger than 8.4 meters didn't exist back then. Instead, scientists considered using either smaller segments that create one large mirror or a grouping of larger 8-meter mirrors working as one unit. The US National Academy of Sciences recommended a 30-meter telescope be the focus of US interests, seeking to see it built within the decade. Scientists at the University of California and Caltech began development of a design that would eventually become the TMT, consisting of a 492-segment primary mirror with 9 times the power of the Keck Observatory. Among existing and planned extremely large telescopes, the TMT will have the highest elevation and will be the second largest telescope once the ELT is built. While not the most expensive telescope ever constructed, an infamous honor which goes to the $8.8 billion James Webb Space Telescope, the TMT has had quite a rocky road to getting made due to constant delays and protests, eventually bringing its construction cost to over $2.6 billion so far. But what exactly made it cost so much, and where is it located? The TMT Observatory Corporation Board of Directors narrowed the list to 2 sites, one in each hemisphere. The first was Cerro Armizones in Chile's Atacama Desert, and the second was Mauna Kea on Hawaii Island. On July 21, 2009, the TMT board announced Mauna Kea as the preferred site. The final TMT site selection decision was based on a combination of scientific, financial, and political criteria. For the scientific research criteria, Mauna Kea's grounds and weather conditions were the best that could be found to suit the telescope's location. There are now a total of 13 observatories on the mountain, with plans to decommission 2 of them to help reduce astronomers' footprint on the mountain. A 14th observatory is currently coming up, under which the TMT will be situated. The big reason why the TMT is highly awaited is its ability to detect biosignatures, said to be the chemical footprint of life. In particular, it will be on the lookout for other planetary atmospheres that contain water vapor or methane. This feature overtakes the JWST and Hubble telescope's capabilities by a mile. According to the TMT website, the TMT aims to study exoplanetary systems, including their formation, evolution, and interconnections, to answer questions such as, is there life outside our solar system? And what can other planetary systems tell us about our own? The study of black holes is another objective. While these have been observed in detail within the Milky Way, the next galaxy is 100 times farther away, and the 30-meter telescope will help get a closer, clearer look. Pretty ambitious, but quite possible. The TMT will also be able to observe and discover how dark energy and dark matter have had a part in the evolution of our universe throughout cosmic time. Using the TMT, explorers will also be able to discover and examine some of the earliest galaxies that formed around the time the universe had just about been created by the Big Bang. We could possibly learn about other galaxies made up of the Big Bang's raw materials as well. While the planning and research for the TMT seem to be going well, with funding coming from scientific organizations of countries such as Canada, China, India, Japan, and the USA, the construction and the approval of it in Mauna Kea have seen nothing but trouble and bad press since 2009. For more than 50 years, telescopes and the needs of astronomers have dominated the summit of Mauna Kea, a mountain sacred to native Hawaiians that's also one of the finest places in the world to study the night sky. However, this is now changing with a new state law saying that Mauna Kea must be protected for future generations and that science must be balanced with culture and the environment. Native Hawaiian cultural experts will have voting seats on a new governing body. The shift comes after thousands of protesters camped on the mountain in 2015 and again in 2019 to block the construction of a state-of-the-art observatory, jolting policymakers and astronomers into realizing the status quo had to change. The protests and bad press regarding the location choice of the telescope have significantly delayed its construction schedule, therefore increasing its budget by over $1 billion from its initial investment of around $970 million. The current cost of the telescope alone has gone up to a whopping $2.6 billion and counting. Due to these issues faced in Mauna Kea, Observatorio del Roque de los Muchachos in La Palma on the Canary Islands has been selected as the TMT's alternate site. This decision is also partly due to its location in the Northern Hemisphere and its ability to also support TMT's core science areas. As of 2022, the construction of the telescope has yet to commence, with research and planning still being done remotely ever since the coronavirus pandemic began. But no one is losing sight or hope for the TMT's construction. After the success of the James Webb Telescope's defined pictures of planets and a black hole, scientists and the public are aching to see more of the universe. The eventual impact that the TMT could have on us will be massive, providing information not only on life outside of our Earth and our galaxy, but also on habitable planets for the future of the human race. What are you most excited about the TMT discovering? Let us know in the comments below, and be sure to subscribe and click the bell to catch up on some more fascinating videos.